Hi all, this is Vasvi from At Home Tuition. Today let us learn something about the frustrum of a cone. First let me tell what the frustrum is. When you take a cone, okay, this is the whole cone inverted, and here if you cut smaller portion of this cone from the tip and parallel to the upper this round side, okay, you cut a smaller cone and then the remaining portion is called frustrum of a cone. Okay, so here what we have is, for the whole cone you have a radius, you have a height, and then you cut a smaller cone from this of a specific height, right? This would be something lesser than this, and the radius will also be lesser than the previous radius. Okay, so when you take away this, the volume of the bigger cone minus the volume of the smaller cone will give you the volume of the frustrum. Okay, so this is the basic idea of frustrum, and you have few formula for this shape, that is the frustrum. The volume of the frustrum is 1 over 3 pi h times r1 square plus r2 square plus r1 r2. So here your r2 is the smaller radius, okay, this is your r2 and this one is your r1, okay, and the height is the height given, the height of the frustrum, okay, it is not the height of the cone. The formula for the CSA of a frustrum is pi L. L denotes the slant height, okay, pi L times r1 plus r2, that this the sum of the radii, okay, and the TSA, the total surface area, would be, you add up the CSA plus twice the base area, right? So here pi L times r1 plus r2, this is the CSA, plus the base area at the bottom, the area of this bigger circle, that is pi r1 square plus pi r2 square, the smaller circle, okay, the area of the smaller circle. So these are the formula we are going to use to solve the problems here. Let us see how to work on it. So here's the first question given here. A fez, the cap used by the Turks, is shaped like a frustrum. Okay, here's the cap they use. It is in the form of a frustrum. You have a circular top and at the bottom also it is circular in shape. Okay, and if its radius on the open side is 10 centimeter and the radius at the upper base is given as 4 centimeters and its slant height, the slant height is 15. Okay, find the area of material used for making it. So as per the formula, the smaller radius will be R2 and the bigger radius is R1, right? So I am going to write the informations given in the question. So that is the R1, the bigger radius. So that is given as 10 centimeters and R2 is 4 centimeters and the slant height L is given as 15 centimeters. This is a direct question. They've asked you to find the area of material used for it. Okay. So what we do here is, you need to find the CSA, right? The curved surface area of this cap, and you need to cover the top portion, right? So you have to take the area of the upper circular end alone. Okay. So the formula is, so area of materials used will be the CSA, the curved surface area, plus area of upper circular end, right? So that means the CSA, you know the formula already, it is pi L times R1 plus R2, right? So CSA is pi L times R1 plus R2, okay, this is the CSA, plus the upper circular end is nothing but a circle, right? So we use the formula pi R2 square. You have to take the smaller radius for this, okay, R2 square. Let me substitute the value here now. So that is pi, and your L is 15, right? Pi times 15 times the R1 and 2 you have to add, so that's 10 plus 4. Plus here again you have a pi and r2 square, that is 4 square. Got it? So that is equal to, this is 15 pi times 14, right? Plus 16 pi. So that is equal to 210 pi plus 16 pi. So that is equal to 226 pi. Okay? Give the value of pi now. That implies 226 times 22 over 7, right? And that will give you the answer as 710.29, and the unit is centimeters here, so it is centimeter square. Is that clear? That's it. Now let's move on to the next problem. Here, a container opened from the top, made up of a metal sheet, is in the form of a frustrum of a cone of height 16 centimeters with radii of its lower and upper end as 8 centimeters and 20 centimeters. So I have drawn it here respectively. Find the cost of the milk which can completely fill in the container at the rate of rupees 20 per liter. Also find the cost of metal used to make the container if it's cost rupees 8 per 100 centimeters square. Okay. So here you need to find two things. One is the capacity of this vessel, the container. So the capacity means the volume, right? Okay. And they have given you for every liter it is rupees 20. So what would be the total cost of milk that you can carry in this container? And also they ask you to find the cost of the metal sheet used. For that we should know the area, right? The curved surface area plus the bottom, because they say that the top of the container is open. Okay. Here it says open from the top. So you needn't calculate this side area. Okay, let's do one by one. First, let me write down what is given. So they have given you R1 as 20 centimeters, and you know R2 is 8 centimeters, and also the height is given as 16 centimeters. Okay, these are the information given. Now first I need to find the capacity. So the capacity means volume, right? How much it can hold. So capacity is equal to volume of frustrum. So I'm going to use the formula for this. Volume of frustrum is equal to 1 over 3 pi h, and this is R1 square plus R2 square plus R1 times R2. Okay. See, the frustrum of a cone you can also find by using the formula, finding the volume of the bigger cone, and from that you can take away the volume of smaller cone, and then that would give you the volume of the frustrum. That is one way of doing it. So maybe that might be a little confusing. So I thought I'll stick on to a formula so that you can all you need to do is just apply the values, right, on the formula. So what happens, this is equal to, I'm going to give the values here, 1 by 3, and pi is 22 over 7, right? Oh, they have asked you to take the pi as 3.14. So let me take it as 3.14 times height is 16 here, times R1 square. R1 square is 20 square plus R2 square, which is 8 square, plus 20 times 8. Okay. I just put the values in place of the variables. That's all. So let us solve this. So this would be equal to 1 over 3 times 3.14 times 16 times, this is 400 plus 64 plus 160, right? 1 over 3 times 3.14 times 16. Use the BODMAS rule. First you have to solve the ones within the brackets, right, within the parentheses, and then only you do the multiplication and division. So I am doing this here. When you add up all this, you get 624. So this would give you, just do the calculation. You can manually do it, or you can use, if you are permitted to use a calculator, use a calculator. And here I am using a calculator, and I got the value as 10449.92. okay. Since this is the volume, I would write centimeter cube, but the rate is given per liter, right? So I am just converting this into liters. So what happens, I have to divide by 1000, right? So that is equal to 10.449 something 92, right, liters. So, or I can just write it like 10.45 liters. Okay, so I got the volume now in liters. Now I can calculate the cost. My cost would be 10.45 times, it is 20 rupees, right? So the cost is rupees 209. Got it? Next, you are to find the cost of the metal used. So for that you need to know metal used is equal to, okay, let me calculate that, CSA plus upper circle, okay, that would be pi R1 square, right, because the upper one is the bigger one. Okay, now to know the CSA, it is pi L times R1 plus R2, okay. For frustrum you use R1 plus R2 plus pi R2 square, okay. Now we need to know the L for this, right? So normally the lateral surface, the slant height is equal to square root of h square, the height square, right, plus, I'll just come back to this picture, I'll tell you what. So you need to know the lateral slant height, right? So what I do is I just draw a line perpendicular like this, okay? The bigger radius is R1 and this is your R2, okay? Now this is your height. So this L is equal to, this portion over here will be the total R1 minus this R2, right? This portion, okay? Because here till here it is R2 and till here it is R1. So from the R1 you take away this R2 to get this portion, that is R1 minus R2, okay? So my L will be h square plus, using the Pythagorean formula, my L square is equal to h square plus R1 minus R2 the whole square, okay? So I am using it here, R1 minus R2 the whole square. So that is nothing but square root of, my h is 16 square plus R1 is 20, take away 8 the whole square, okay? So that will give you square root of 16 square is 256 and 20 minus 8 is 12 square is 144. So your L is equal to square root of 400. So that's L is 20, okay, centimeters. Now I have to find the metal used, right? This again, already we have the formula there. It is pi L. Now you got the L, and here it is R1 plus R2 plus pi R2 square, right? So let me calculate that. Pi, for time being, let me keep it as pi only. Pi L is 20, right? We got it as 20 times R1 plus R2. So that's 20 plus 8 plus, let me keep the pi as it is, R2 square. So that is 8 square. Okay. So that will give you pi 20 times 28 plus 64 pi. Okay. So that's nothing but 624, because this gives you 560, right? Plus 64. So that is 624 pi. Give the value of pi here, multiply it with the value of pi. So you get 1960. I'm just using the calculator for this. 35 centimeter square. Okay. Now let's find. You got the metal used. Now cost of the metal will be rupees 8 per 100 centimeters square, right? So that will be calculated like 1960.35 times 8 divided by 100. Okay, simple. Do the calculation. You will be left with rupees, okay, rupees 156.75. So 156 rupees and 75 paise is the answer.